Sales and Marketing Officer at Sub10, and I would welcome you to today's webinar about the key criteria for choosing the right wireless technology for small cell backhaul. I would like to thank you for your time, and regarding to the webinar, if you have questions during the webinar, please feel free to type the questions in through the webinar software. We've got our head of pre-sales engineering, John Golding, who's on hold waiting for your answers, waiting for your questions and preparing the answers for it. Okay, today's webinar will be about the small cell market in general. It will be about small cell typologies and about how to choose the right technology to backhaul small cell networks, and why we believe at Sub10 that we've found a way of solving the backhaul challenges that occur during small cell planning and small cell networks. Before we go into the details of the technology of small cells and the backhauling, let me give you a quick overview of the trends and outlook in the telecom industry 2013 and the upcoming years. So what we've seen in the last 3 years is that telcos were very tight on the spendings, mainly because of the worldwide economical situation. So the spendings in especially 3G, 4G networks, or in general cellular networks, were cut quite dramatically. At the same time, the mobile broadband demand tripled. So while the investments in the infrastructure went down, the actual customer demand for the services went up dramatically. This is quite key because mobile broadband is already today representing 40% in average of operators' revenues and is expected to grow even further. So depending on which analyst report you're reading, the growth rate over 2013 and the ongoing years varies between 6 to 10%. So mobile broadband is important and will become even more important for a carrier's overall revenue stream. The problem which is occurring now is that because of the spendings cut during the last 3 years and the high increase of demand, the network qualities are going down and down every day, to the point where, especially in dense city areas, operators cannot meet their customers' expectations in regards to the bandwidth and in regards to the service quality per handset. In 2012, this topic came up heavily, especially in countries where operators are in competition with another operator who might have a better network, and especially in countries where mobile broadband was growing even above the global average. This leads to a situation now where global carriers are looking to heavily invest in their network infrastructure with the main goal to make sure that they can deliver the high bandwidth which are currently demanded by their key customers, especially in dense city areas. And I've added some headlines of publicly available articles where major global operators are announcing heavy spendings in their network infrastructure. For example, Deutsche Telecom announced to invest 30 billion euros over the next 3 years in their network infrastructures. AT&T announced to spend 14 billion. A small operator like Telefónica Argentina announced 1 billion in 2012 and 13 to make sure service qualities and mobile bandwidth is increasing again. A big part of these investments, when talking to operators, is going to be invested in small cell networks. Small cell networks are a new topology of networks which is different to the today's traditional network topology. So today in most cities you've got so-called macro cell networks where you've got a macro cell base station on a rooftop, on a high building, or on a big mast in the city center. And each macro cell is covering a square mile or two in this city with mobile broadband and cellular coverage. This is the traditional rollout. It's a I would say, fairly easy network rollout because it's not so many macro cells per city. You have usually high buildings where it's easy to lay fiber to, or where it's easy to put a traditional microwave as a backhaul for the for the macro cell base station. Small cells, compared to that, are much more spectrum efficient. They have a much smaller distance. So typically a small cell is covering 200, 300, 400 meters of an area. So quite comparable to 2.4 gigahertz Wi-Fi access point. It's delivering very high bandwidth in these 200 to 300 meters. So for example, LTE small cells are targeting to deliver 100 megabits throughput, divided by much less customers per base station than a macro cell would be, where a macro cell, for example, is covering an area of thousands of people. A small cell will cover an area of maybe 100 people only, and therefore every single user will have a much higher bandwidth available. When talking about small cells in dense city areas, we're talking not one base station per square mile or maybe 2 per square mile. We're talking in average between 15 to 30 small cell base stations per square mile in dense city areas. So you can imagine that when macro cell backhauling sometimes was a challenge, for example, by laying fiber to a building or by getting the frequencies approved for a traditional microwave to backhaul the base station, then you can imagine what kind of level of challenge backhauling will become when we're talking 15 to 30 base stations per square mile. And not base stations which are installed on rooftops or masts. It's small cell base stations which are typically installed on lampposts or city furniture or on a wall of a building in the first or second floor. So somewhere where you cannot use, for example, traditional microwave, because imagine a lamppost with a traditional microwave radio on it. It doesn't look good, and most cities probably won't even approve it. At the same time, laying fiber to a lamppost to connect the small cell base station is also in many cases not an option. It would take too long, it's way too expensive, and it's just simply not practical when you're talking about rolling out a huge city like New York, Berlin, London with small cell networks. It would take way too long and would be way too expensive. This is why when you're reading analyst reports, most of the analysts believe that around about 70 to 80% of small cells in a dense city area will be backhauled with wireless technologies. When talking about wireless technologies for small cell backhaul, then it is becoming very important to choose the right wireless technology. Traditional microwave, as I said, is in most cases not an option, because having a 30 or 60 centimeter antenna, a big outdoor unit and everything on a lamppost simply is in many cases no option. When talking to major carriers and operators, we found in general around about 5 key criteria that a wireless technology needs to meet in order to be applicable for small cell backhaul. The first, and the one that was prioritized as the highest priority, is a small and smart form factor. And the key sentence we always heard when talking to operators is, your wireless technology is not supposed to look like a wireless backhaul link. Make it look like part of the lamppost. Make it look like something, but not a wireless backhaul link. So form factor is very, very important, because form factor will, in the end, be the key decision criteria for a city council to allow an operator to install their infrastructure on city furniture and lampposts. Another key criteria regarding the throughput is, depending on which operator you're talking to, between 100 megabit and 1 gigabit throughput per link. The operators that are demanding 1 gigabit are mainly thinking about long-term bandwidth demand. In average, a small cell in the next 2 to 3 years will need maximum 70 to 100 megabit. Nevertheless, having a gigabit already installed obviously is a future-proof decision for a long-term rollout. Another quite practical decision criteria is a high density of links. So when you look, for example, at technologies like 5 gigahertz, when you look at 2.4 gigahertz, then high density won't be physically possible because these spectrum bands are already quite polluted and have a very high likelihood to create interference problems. So density is very much related to interference in this case. The next point is no interference and especially the spectrum availability. So the wireless backhaul technology for small cell needs to have a high spectrum availability. The spectrum needs to be there, the spectrum needs to allow high bandwidth, and the spectrum needs to allow hundreds of links per square mile to be installed. Another criteria, and this is actually a criteria which is just popping up recently, is the implementation of SYNC-E and 1588 into the backhaul technology. That is so important because, especially when talking about small cells, the synchronization of the base stations will become a critical factor for a reliable, interference-free small cell network. And the wireless backhaul technology needs to be capable to push the synchronization signal of the base stations forward and to allow a network synchronization all over the complete infrastructure, including the wireless network. We at SAP10 believe that 60 gigahertz is the frequency which is best suited for a small cell wireless backhaul technology. The reason why we believe that 60 gigahertz is the right technology to go for is the physical specs of this frequency band. You've got a very high sharp oxygen absorption of up to 16 dB per kilometer, which limits the links very much in its range. So for example, our technology is capable of transmitting data of up to 1.2 kilometer distances. But this limitation of distance in small cell networks is not crucial because most of the cases, the small cells will only be 200 to 500 meters apart from each other. The benefit of such a high oxygen absorption is that you have a very little likelihood of interference. The absorption, as it says, absorbs a lot of the interference problems and allows you to install a high density of links in combination with narrow beam antennas, in combination with using a technology which is very spectrum efficient, like the links provided by SAP10. Another benefit of 60 gigahertz is that in many countries, 60 gigahertz has been assigned by the regulators to be a license-free or light license frequency. Other countries, like for example Italy, are currently looking at opening the frequency under the same specs. But when you read the frequency regulatories at FCC, CEP and ETSI, then it recommends a light license regime or a low license or no license regime. And when you read the regulatory statements, you will find that the purpose of not regulating it is not to make it the next 2.4 or 5 gigahertz technology. The simple reason for it is that the regulators didn't see the need to regulate its frequency band because of its very little likelihood of interference. When looking at the small form factor demand, which we're getting back from the operators, then we have launched a broad portfolio of products of wireless backhaul links in the 60 gigahertz space, which have this small form factor. And this is one of the key benefits of our technologies today, that our wireless links don't look like wireless links. And at the same time are designed to meet very robust interference, very robust outdoor environments. Our infrastructure only weighs 2.5 kilo per end. It is an all-outdoor solution with IP68, and it can be even powered directly by the small cell base station. So you wouldn't even need a second power supply to backhaul your small cell base station on a lamppost. It can be powered through Ethernet through the base station. At the same time, we have implemented a patented snapback synchronization. So snapback is basically our brand name for the synchronization topology. It's on top of Sync E and 1588. It basically guarantees that the sync signal is re-established over our wireless backhaul solution within seconds instead of hours. And when you read the Sync E specs, then you will find that Sync E as a spec leaves up to 30 hours for a vendor to re-establish the synchronization signal. This is in theory already a problem, but in practical, this basically means that as soon as the small cell base station goes down, it can take up to 30 hours to get the sync signal back. And at the moment, with our snapback, we will be able to do that within seconds or even microseconds. We can do a true gigabit full duplex with our products. You see an example here where Vodafone, during the Mobile World Congress, installed our link at their booth, and they showed their customers on a screen below our link how Vodafone is going to solve the bottlenecks in small cell networks with a sub-10 technology. They were basically running a gigabit full duplex live over the link, and they could show the low latency and the high bandwidth of our link and the net available throughput of 1 gigabit. Another example of an installation for a carrier is in the city of Vienna. What you see here is the connection of two macrocell sites where our link is installed on a wall mount installation. And what it shows is that, and I've been at the street, when you walk down the street, you don't realize that there is a microwave or a wireless backhaul link installed on the wall mount. Only when you know it's there and when you look very carefully, you can actually see that there's something installed, but you can't tell that this is an antenna. You can't tell that this is actually transmitting data over the street. And that's the purpose of the small design and the small form factor of our technology. What you see here is two examples of a high density installation. The left one is in the city of Zurich, where we are transmitting 4 gigabit on this one mast. So it's 4 gigabit links, which are of which 2 are transmitting in the same direction. This is a carrier installation, and it's for a macro cell backhaul in 60 gigahertz. On the right side, you see a picture of a 4-link installation on our headquarter in the UK. It's 4 V320s, which are transmitting 320 megabit each full duplex in the same direction without any interferences. And the opposite side of the links is only 30 meters apart. So it's very closely installed together, and it's a very short distance, and still we don't see any interference on this installation. And we've done this installation in order to show operators and major telcos and decision makers at major telcos that sub-10's technology is meeting what we promise. So we have had a lot of visits of major operators at our headquarters who were running through different trials, and where we could prove during trials and visits in our headquarters that our technology can do what we say and that the density levels are as high as we promise. Another example which I like to mention is a carrier case study in Austria. It's a project which we have done together with our partner Alcatel-Lucent, and what you see here is part of the network plan where we are backhauling macro cell sites for this operator. The reason for the operator to go with 60 gig was operational expenses. So in Austria, traditional microwave frequencies are very expensive, whereby 60 gigahertz frequencies are license free. And what you see here in the middle is a site with 9 links, where we had to prove on that site for a time frame of a couple of months that our links are not causing interferences, that our links are carrier class, and that our links can provide a carrier class service over a long time, even when rain starts coming in, when winter starts coming in, so under harsh environments. And this mast was the reason in the end for the carrier to decide to go with us and to roll out a network in the city of Vienna consisting of around about 100 links, which is saving them hundreds of thousands of euros every year by moving from traditional microwave to 60 gigahertz for their microcell network. This is an installation which is up and running since around about 2 years now. And up to now, we haven't had any problems regarding weather or any problems regarding service quality from our wireless backhauls. In summary, for an operator, 60 gigahertz and sub-10 technology delivers, say, 3 key benefits. The first one is the quicker time to market, especially when talking about small cells, which is thousands or 10,000s of base stations per city, 10,000s of wireless links. Then 60 gigahertz has the benefit that you don't have to wait for frequency application time. If, for example, a small cell has to be moved from one lamppost to the other, you don't need to reapply for a frequency. You can simply move the wireless backhaul link together with the small cell base station. You have less site acquisition efforts because our technology is very small. It's very easy to install. So your sites need to be much less robust. And this again is a key benefit, especially when talking about installing small cells on lampposts, because the lampposts that sub-10 is requiring, the lamppost stability is much less than if you go for a wireless backhaul solution with a, let's say, much higher footprint. Lower operational expenses is another one. So in most countries, you have no or very little frequency cost. You have less installation time. So when talking, for example, to our partner Alcatel-Lucent, then Alcatel has proven that our links only require around about 25% of the installation time of a traditional microwave link and around about 30% of the installation effort of a traditional link. And that is definitely a key decision criteria when you look at the overall costs of a small cell network rollout. It's important when you install 1 or 2 links, but it will become a major cost factor and cost reduction factor if you look at installing thousands of links in a city. Our links deliver much better coverage because of the high network density and because you can do the backhauling at street level due to our low footprint and our small form factor. In summary, we believe that 60 gigahertz is best suited for small cell. Nevertheless, you need to choose the right vendor with the right features, including synchronization, including 1588, including high spectrum efficiency of the links. We believe that the size of the products in the future will decrease even further. So sub-10 has a very compelling roadmap of new products which will be launched over the next month and even second generations the year after, which will make these links even smaller than they are today, and which will help to roll out small cell networks even more efficient than today. In case we have raised your interest, in case you are an operator or you are an integrator working with an operator, please don't hesitate to contact us. We've got an email address, which is info@sub10systems.com. If you write an email to this email address, the sales team, the key members of the sales team, the service teams will receive your email and we will promptly reply to it. We can get you more information about our small cell backhaul solutions, our patented synchronization methodology, and also about the compelling portfolio of our products of 60, but also of 70 and 80 gigahertz backhaul solutions. Thank you very much for your attention. And if you have questions now and you don't want to wait for an email from us, please feel free to ask John through the webinar control panel and we can reply your questions right now. Thank you very much and have a nice day.